see from past studies from 66 and 77 in the United States that they concluded to be able to save 5 or 11% of the total primary energy consumption. And because the total primary energy consumption is today linked to 86% to fossil energies, means that we can save by using tribology technologies. Consequently, we can save 5 or 11% times 86% of the total primary energy and CO2, what is a considerable contribution. In a more recent study, ARPA-E in the United States, they concluded one can even save up to 24%. Regarding where, here we see in the past studies that around 1.25 up to 2% of the gross national product can be saved, not the total cost, if tribology is applied to reduce the resource consumption. And because the generation of resources generates inevitably also CO2, means if we not only look on the primary energy but also on the resource consumption, we have a second lever to reduce the CO2 emissions in future. Regarding the total expenditures of a national economy, you see here that we have at least 2.5% up to 12% and even more of the gross national product is related to wear, and wear means always you have to replace a component, you have to replace a system, and this means you generate waste and you consume resources. And it is already here clear that if you make in future lubricants and additives based on renewables, you reduce or you improve sustainability. Then we have 50 gigatons of fossil energy sources, coal, gas, oil, everything which comes out from the earth. And if we reduce the friction significantly, we lower the primary energy consumption and CO2. If you put all studies together, the old and the recent one, you can say that between 8% to 24% of the total primary energy can be saved by reducing friction. If we apply this now to the global CO2 emissions, then tribology and lubrication is the most significant technology to reduce CO2. Some people question if we should stop to work on lubricants because e-mobility and electrified powertrains are coming. The good news is that even those will have gears. They will need lubricants because they have a reduction gear or they have a 2-speed gear, maybe in the future a 3-speed gear. Second, they use more roller bearings, so at least more greases will be needed, let's say 1.5 to 2 kilograms per vehicle. We will need functionized coolants for batteries, especially for high power systems, which can have 20 to 45 liters. And we still need gear fluids for high-speed planetary gears, differentials, meaning 4.5 liters per vehicle, and also fast charging cables above 300 kilowatt will need an internal cooling. But also here in an e-vehicle, still friction reduction is of importance because it transduces for an e-vehicle directly into range and in a combustion engine for fuel economy or for CO2 emissions. Challenging for those applications is because we had very strong magnetic field and electrostatic charges that the question of arcing and electrosparks is a nuisance which must be solved in the next time to have reliable electrified powertrains.
Look, I'm an absolutely strong advocate of sustainability. You can probably tell by my background, I'm very passionate about it. And at the start of the panel discussion, Bernard, you mentioned that sustainability is a differentiator, and I couldn't emphasize that piece enough. I know Larry Fink from BlackRock, he recently said in his annual letter to CEOs, I think it might have been last year, that climate change has become a defining factor in companies' long-term prospects. You know, there's a climate risk that we are presented with, and we need to take action to try and improve on it. So the responsibility sits with everyone, and I think this presentation really emphasizes the fact that we are in a unique opportunity, that lubricants contribute to this naturally, but the figures show that there's so much more that we can and have to do here. So there was two areas that really struck a chord with me. The first one was the table you had on friction saving potentials on internal combustion engines. And here you mentioned about the 1 to 4% fuel saving per reduction based on the dynamic of this. And I pulled out a figure from one of your reports, which takes that logic out a step further, and it looks at the German road traffic annually. And just to put a bit of context around that, the 1% in fuel saving could result in the 170 million tonne of carbon dioxide emissions being reduced by 1.7 million. That's, to me, it's a phenomenal figure. It's an incremental start, but something that can really make a big difference.
One point that you are raising is really critical and very clearly highlighted in the Sustainable Development Goals. If you go look at Goal 17, talks about partnership and collaboration. This is not something that any company can solve in isolation. And it needs some effort and concentrated and consistent effort across the industry to change. You know, we're saying that there is a shift now in our OEMs between the internal combustion engine and electric vehicles. You know, the funds for research and new technology development have not doubled, but they have now to deal with the internal combustion engine that will be still around for a long time and developing the new technology for the electric vehicles. So they have to find efficiencies and better ways of working, which means you cannot retain the model that has served you in the past. If you develop technology, develop new technologies, renewable technologies, new additives, new lubricants, with the same process, the same mindset, and the same thinking of the past, we won't be able to proceed in any direction because we cannot fund everything at the same time. So you were right when you talk about changing a business model, changing the way of thinking, looking at how to be smarter. You know, we've been working in this area for Infineum is 40 years, for many companies might be more than that. And we have a lot of understanding that we can actually apply to developing new technologies in different ways, changing the standards, the ways of work, changing the investment hurdles that there are for bringing new technologies to market to make them more affordable. The reason why the environmental acceptable lubricants don't have market share, because they are expensive. Why are they expensive? Because we pass on the cost all the way to the end customer, and we expect the end customer to pay for it without creating the benefits that goes with it. So the industry has to change the way of working to enable this change to happen.
But I think the lubricant industry and Tribology is in a good situation because we have the technological bricks. We must only assemble them and bring to market. And as you said, the best example are biolubes. They are existing since 30 years, but the market penetration is low because they are too expensive, much more too expensive. But the lubricant industry has the technology available, but how it will be organized, because you cannot mix an ester with a polyglycol. You cannot. You have miscibility issues. You have supply chain issues, distribution issues, which can be solved. So the lubricant industry, for my understanding, is not in the situation that they need 5 or 10 years of R&D. They need now new business models and the willingness to bring this into market. Also with the end users, if you look, if you take an engine oil specification, it is written around hydrocarbons. And now you come with 100% ester or 100% polyglycol engine oil, it will never fit.
As Maurizio was explaining, that we really need the partnerships and cooperation across the value chain, really to establish common ways to actually measure and report sustainability in comparable way, so that you can actually show and market the benefit for the end customer and for the OEMs, why you should maybe pay a little bit more for a bit more new and more sustainable solution compared to the previously maintained business models allowing components and solutions that have been working quite well so far.